Hi everyone. Now we will discuss about next topic called register. What is this register means? If you go with the analog electronics, the register meaning is entirely different. We are talking about here the digital portions. So register means here already we have studied about some flip-flop. If you make some group of flip-flop, whatever the things outcomes, that is usually we called as a register. Simple name, the group of flip-flop is known as register. What is this flip-flop means? We know that flip-flop is a 1-bit memory cell. So finally we can call as the group of memory cell is nothing but register. In easy method we can say that register is nothing but a memory. Depending upon how many register we can do it, according to that we can design the flip-flop. If you want to do something called as a 4-bit register, so you require 4 flip-flop because each flip-flop stores 1 bit memory. So you require how many bit according to that much of flip-flop necessary for the register. If you go into the type of register, we usually make up this is a 2 type. One is the register which is not transferring and it is always constant. For this we are calling as a storage of register. And another one, we are shifting that one or transferring data from one part to another part. This register usually we call as a shift register. In our cases, many part we are discussing about shift register. Storage register also a part of PIPO. What is this PIPO is nothing but parallelly input we are given and parallelly output we are taken and there is no transferring of data. So this method is known as storage of register. In shift register, we can make as many type. Main type is we are calling as a serial shift. Another one we are calling as a rotate. So the serial shift means it is one side we are giving as an input, another side we are taking as output and it is serially shifting. Rotate means there is a continuous shift and whatever you have there in the LSB, it's going back to the MSB and MSB is to the next bit. So on it is rotating itself. It's like a circle. But in serial what happens? You are giving something input, output is going or what we call output is vanished and new input is coming. This type is called as a serial. So in this serial we can make as a 3 type. One is usually we call as a SISO. That means serially input we are giving and serially we are taking as a output. Another one we are calling as a SIPO. That means we are giving serially in but we are taking in parallel. But it is also shifting register, so it is part of the serial register. One more is we are feeding as a parallel but taking in a serial. So it is called PISO. These are the 3 types in the serial shift register. In the rotate, we can usually make as a 2 type of rotate. One is called as a ring counter. So it is nothing but ring rotate, ring type it will rotate. Another one is called Johnson ring counter. This is nothing but the MSB bit whatever we have that is shifting like a complement to the LSB bit. In ring counter what happens? MSB bit shifted to the LSB and it's going on. But in Johnson, MSB is not directly given to LSB, complemented form given to the LSB. This is known as Johnson counter. Later we will discuss more on this part. First we will discuss about these 4 types. Here, before going to anyone, each SISO and SIPO everywhere we can do 2 types. So what are these 2 types? One we can do as a right portion or right shift. Another one is called as a left shift. So left serial also possible, right serial also possible. If you take one number, something called 0010, if this 0 is going to left side and this 1 is going this side, this is called as a left shift operation. If it is same number if you are taking and it is going on the opposite direction, this 0 here, this 0 here, this 1 here like this, this is called as a right shift operation. Each portion serial, that means SISO I can do right and left, SIPO also we can do right and left and PISO also we can do right and left. Similar way, in Ring and Johnson's also we can do right and left possible. In discussing part, I will do only left portion. Whatever we are doing in left, that opposite is right side. So when you are doing left side, I am taking from LSB to the moving towards to the MSB. Now we can check what is this each register works or how it is going on. If I take the first one as a SISO, so what happens if you take this one as a your LSB bit and we are calling some name card as a Q0, and this one we are calling as a Q1, and this one we are calling as a Q2, and this one we are calling as a something called Q3. So in this case, if you are giving as a serial in serial out means it is I am talking about left shift. So what happens when we are giving serial input to the left side? So here we are giving serial input. In the first case, what happens? We will give serial in one by one. First, actually I want to give first number is 1. So here LSB bit is 1. Other we can take as a don't care. That means I don't know what is exactly present. If you give second number as a 0, so here 0 is present and this 1 is moves here and these two are don't care. Similar way, if you move one more number 1, so here it is 1 happens and this 0 moves here, so go on like this, the number will changes. So this option and output we are taken from the last portion. This is called as a serial out. So if you take from the Q3 as a output and you are feeding something to the Q0, this is known as SISO, left side. If it is right side, it is opposite. Q3 you are giving input and Q0 you are taking output. If you are going with the SIPO, here usually any shift register we are using D flip-flop because whatever we are feeding, same answer come to the Q. Each clock pulse we are changing this bit, so it will changes in the each clock pulse. So when you are moving in SIPO, what happens? We are feeding as a serial in only 1 0 1 1 whatever number, but we are taking directly from the all these values Q0, Q1, Q2 and Q3. So this is Q0, this is Q1, this is Q2 and Q3. All these four I am taking together output. The difference between serial and parallel means one by one we are giving, and if it is parallel means all together I am taking. So the changes is serial in means always remember that if you are talking about left side, always the serial in is coming to the D0 and it is nothing but output is always from the Q3. This is for the serial in and serial out. If you are talking about parallel in if you are talking, you have to give from all the parallel in like D0, D1, D2 and D3, and parallel out means we can take from all the output like Q0, Q1, Q2 and Q3. That is the difference between serial and parallel. So in this SIPO what we are done, we are giving input from the D0 and we are taking output from all these three. That means this is serial in and this is parallel out. Similar way we can do one more called as a PISO. So parallel in serial out meaning is here we are giving as a input from parallel. So we can give input together here like this is D0 and this is D1 and this is D2 and this is D3. So from here if you give one number called 1 0 1 0, so everything will come directly. So 1 0 1 0. This is what D0, D1, D2, D3 given. Now you can take as a serial out. Remember here serial out means I have to concentrate on only Q3. So whatever in the Q3, this is only comes. So in the first case Q3 come 1, then after to the shift of left, next number 0 will come. Then after 2 clock pulse 1 will come. After 3 clock pulse 0 will come. Like that we will concentrate on only Q3 and we are taking from output Q3. If you are going with the last one PIPO, usually we call this is not a shift register. This is a storage register. That means whatever you are feeding here, suppose you are taking from D0, D1, D2, D3, 1011, directly this one you are taking as a output. There is nothing shifted here and no transfer of data occurs here. So actually the PIPO is a very easiest one, and if anywhere you want to just store it, not do any process or any operations, then we are using this PIPO method. Now, if you are talking about the another portion that is called as a rotate. So if you take rotate, what happens? This is the similar case. Input is D0 and anyway output is Q0. Similar way here we can call as a D3 and Q3. So D0 is our LSB bit and D3 is our MSB bit. Rotate means what happens? If you take as a rotate left, so if you give one number 0, 1, 0, 1 some number, so what happens? This 0 comes next to here and this 1 comes here and this 0 comes here, and the thing is this 1 comes here. This is called as a rotating operation. Previous serial operation, what happens? We are feeding new things every clock and getting output in the MSB bit. So this portion happens in the serial data. But in rotate, we are not feeding any input or not taking output. We are only rotating the circle wise. So here left also possible, right rotate also possible. In this rotate part, first one is known as ring counter. Ring is exactly same as rotate operation. So if you want to do right shift, so if you take one number, same number, 1 0, something called 0 1, so what happens? This one moves here, so next number is 1 here and this one here and this 0 here and this 0 here. This is the right shift, how it is going on. For left shift, what we are discussed here. So similar way we can do one more counter called Johnson counter. It is nothing but rotate only. The difference is if you take one number 1000, what happens? If you talk about the left shift, so it is moving towards to this direction. So this is 0 and this is 0, this is 0. The thing is this one whatever is there, I cannot use directly here. If I use directly, it acts as a ring counter, but I am taking complement of this, so it becomes 0 here. Similar way it is progress. So this type of counter usually known as Johnson counter. Similar way if you take one more example 1000 and right shift means what happens? The opposite way. That means the 1 is shifted here, this 0 shifted here, this 0 shifted here, this 0 is going with the complemented form and coming here and 1 here. So we getting as a, sorry, this become 1 because of this shift. So 110 is the our answer. In this method we can do the ring counter, that means rotate counter also or rotate register also, and we can do the something called as a serial register also. First we will discuss what is this serial register, how it works. I am talking about SIPO. So what is this operation? What is truth table? What is clock diagram? And how to draw the circuit diagram. So SIPO name itself says we have to give serial data input and parallelly we are taking Q0, Q1, Q2, Q3. Each clock pulse it is varying. So the easy purpose we are using D flip-flop. Whatever changes, same thing happens to the Q portion also. So this one I am taking as a D0, so it is the LSB bit, and this is Q0, and this one I will call D1, Q1 because it is left shift. So from the LSB to MSB it is moving on. So this one I am calling D2 and Q2. So next one D3 and Q3. So what happens when you give serial data? So 0 is given to the Q0. Q0 is nothing but D0. So here we are moving the serial input. So when you move serial input, I don't know what is there in the Q1, Q2 and Q3 because it is maybe 0 or maybe 1 previous values. So first when you feed as a 0 here, if you feed as a 0, I don't know what is there in this portion. Okay, and what is there in this portion and what is there in this portion, but I know the output of this one is 0 here because of serial input I fed 0. Second clock pulse, I want to feed 1 here. So what happens, next clock pulse, this 0 shifted here, so I am getting 0 over here because of these values. So this is shifted to this part, and this is anyway I am having don't care only, and this is also don't care only. When you feed 1 here, so this become 1, and because of the clock pulse, the Q0 is you have to give to the D1 connection. So something connection here. So what happens? This 0 is connected here. Similar way, you can connect to Q1 to D2 and Q2 to D3. So this connection will make as the output portion, and we have to take from Q3. So this is our serial output. So we can go with the next part here. The 0 is shifted here, and anyway don't care of these two portions. Now what happens? Once you give another number, this is the second number you are given, third number assume that I am giving 0. When you give 0, so what happens? This 0 is shifted to here. And anyway, this is don't care. And what happens? This 0, this 1 is shifted to this portion. So we are getting as a 0, 1, 0 don't care. Nothing but this 0 is input here. So this 1 is shifted here, and this 0 shifted here, and this is anyway don't care. Similar way we can do the last case. Last case we are using one more bit 1 here. When you use 1, here the previous bit is going to the 0, and this bit is going to the 1 here, and this bit going to the 0 here. Because of next clock pulse, the whatever Q2 you are given to the D3, and whatever answer D3 get, same thing to the Q3. So what happens? This 1 is taken here because of serial input, and this 0 shifted here, and this 1 is shifted here, and this 0 is shifted here. So you are getting as a 0, 1, 0, 1. This is called as a parallel output. Parallel output means I am taking from Q3 also one output, and I am taking from Q3 also another output, and Q1 also another output, and Q0 also another output. Here serial output is not required because we are discussing on SIPO, so only parallel output is enough. So parallel output means Q0, Q1, Q2, Q3. So each portion we are taken, and this is the output what we got. Now what we are fed, that is the output here. Here 0, 1, 0, 1 is given input, and we have to take from MSB side. So it is 0, 1, 0, 1. So our answer is proper. So whatever input we are given, output we are getting in the MSB to LSB. If you go with the clock signal, what happens here? First I have to feed the serial in the each clock pulse. So the first clock pulse, that means here to here I am talking about first one, and here to here I am talking about second clock pulse, here to here third clock pulse, and I am taking as a positive edge. You can take negative edge also possible here, and this portion I am taking as a fourth one. So what happens in the first one serial? We are giving 0, so make it 0, then it is 1, then it is 0, then it is 1. This is what you are given, 0, 1, 0, 1 serial input. So what happens to the Q0? First Q0 is first cycle it is 0, so first cycle it is 0, then it is 1, so 1 and 0 and 1, because serial input is given directly to the Q0. So whatever input you are given, Q0 you will get same. Now come to the Q1. What happens? First Q1, I don't know what is this condition, so we will make something called like this, don't care, okay? Because this may be anything, either 0 or 1. Next condition, I am getting as a Q1 0, then it is 1, then 0. So I will get as a 0, then it is 1, then it is 0. So this is how you are getting Q1. Similar way, try for Q2. Q2 is first 2 cycle, it is nothing but don't cares. So make it something don't care like this. And then what is Q2? You are getting 0, 1. So make it 0 and then 1. Similar way, you can draw the Q3 also. So Q3, first 3 cycle, nothing we are getting, make it don't care. And last case, you are getting as a 0. So parallel output means we are taking from the last bit. So whichever in the final portion parallel, so it will get all the portion. So here we have 1, here we have 0, here 1, 0. So we are taking from this direction MSB to LSB. So 0, 1, 0, 1 is what given that answer we got. So this way you can draw the clock pulse also, and you can draw the truth table also, and this is nothing but a block diagram. Here remember that we are using always synchronous because the clock pulse actually work in a same time. For asynchronous it is very difficult, and it is we have to use in a different technique. So always remember, when you are doing any type of shift register, you have to use synchronous flip-flop. Next, one animation I will show you how it actually works. The previous step we are discussed on each particular block diagram and clock pulse and how to write the truth table for your examination purpose. Now we can check with the animation. You can try that how actual the working on here. If you give as a first clock pulse, first input I will give as a 0. So whatever the input I am given, that will shift here. So here we have to give something called as a 1 0 1 1. So first bit 1 I have given, and see first bit I have given as a 1. When the first clock pulse is given, so this 1 shifted here and this number becomes 0. So the first number actually 1, and we don't know anything about these portions. And second number when you are given, so this becomes 0 and this 1 shifted to the next number, and these are again don't care. So when you give one more clock pulse, whatever here 1 the shifted here, so this 1 shifted here, this 0 shifted here, this 1 is this side. Again if you give clock pulse, the 0 shifted to this side, so what happens, this 0 is shifted to this, 1 is shifted to here, and this is don't care, and this 0 shifted here, this 1 shifted here, and anyway new number is 1. So we are getting as a 1 0 1 1. You have to take from MSB. So this one is 1 0 and 1 1. This is how you have to do the serial in, parallel out, shift register. Now the next part, SI SO. So whatever we are done in serial in, parallel out, the same procedure we have to do here. The extra clock pulse we have to give, and we have to take that one, and only we have to concentrate on Q3 here. The similar setting you have to take as a previous. Settings are here D0, here D1, and this portion is D2, and this is D3. Similar way, this is Q3, and this one is Q2, and this one is Q1, and this one is Q0. So our aim is to give as a serial data in. So whatever here we are giving as a serial in. Serial in we will assume to give as a something called 0101. So first we are giving 0, then we are giving something called 1, then we are giving 0, and then we are giving 1. What happens when 0 is given? The circuit diagram similar to previous. So previous output is connected to next output. Similar way we are connecting here, and our aim is we have to take from Q3. So this is our serial output. So I am not worried about what is the output of Q0, Q1, Q2 getting. Only the concentrate on Q3 here. So when you give as a first clock pulse 0, what happens? Usually these conditions we don't have anything. So this is don't care, and this is also don't care, and this is also don't. This 0 is going here, and we don't know about all this stuff. So all these are don't care. Next, we are moving to the next number. That means we are feeding one more number called 1. So, when you feed 1 here, this 0 is shifted to this portion. So, the next output, because here we have Q0 is 0, when you give clock pulse, this 0 going to the D1 and that is the answer of Q1. So, 0 comes here. Next what happens, the don't care actually here, so whichever that number we don't know, that don't care here, and this don't care whatever number either 0 or 1 is coming to this portion. This is the second part. Up to here we discussed, and what happens, this is 1 here, so this 0 shift here and don't care and don't care, and after also we know that here 0 comes and this is 1, this is 0 and this is don't care, and similar way we have here 1 and here 0 and here 1, here 0. This operation you people know in SI PO. So next what happens, here we are not feeding anything, so this one we can take as a don't care, because either 0 or 1 it will appears and it is not a necessary here, and this one moves here and this 0 here, this 1 here. Again what happens to next, this 1 is moving here and this 0 is moving here when you're giving next clock pulse like 5 and 6. In the 7th clock pulse what happens, this 1 is moving this here. So whatever output we are getting in this portion is known as serial output. So that is called 0101, and we are not bothering about these three output. This is just for understanding purpose written. If you write in Q3, it's a enough. And serial data, whatever we move, that is 0101, same answer we got in SI SO. So in this case what happens, the similar operation here, up to 7 clock pulse you have to go. First we will get 3 don't cares, then we will get first 0 from this portion, then we will get as a the other portion like 0101. This is the what output from the serial output. Similar way, if you want to write the clock signal, first write the data signal. So data signal is nothing but in the first portion it is 0, so go with 0, then it is 1, and then it is again 0, and again it is 1. So it is nothing but whatever number given serial data in. And what happens to the Q3? Q3 what happens? First clock pulse it is not working. Up to 3 clock pulse it is not there. So this is your first clock, this is your second and third clock pulse. Up to third clock pulse we are not getting anything to the Q3. So we can call something like this. This is don't care. Either it is 0 or 1. Then we are getting the answer. So first one is 0. Then we are getting as a 1. Then we are getting as a 0. Okay. And last clock pulse we are getting as a 1. So whatever answer here given 0101, the same answer you got in the final answer. So this is what how to write the clock signal in the SI SO. This is all we are talking about left shift. You can do similar operation in the right shift also possible. Once we can check out how actually serial in and serial out works with this animation. So actually each clock pulse when you are given, the next flip-flop it is going. So the number first I have given 1, so it will shift to the next bit, and then that one shift to the next bit when clock pulse. Again that one shift to here, that one shift to here, and last clock pulse is shift to the Q4. So once you are given any input in serial data, after some times, that means it is taking some time to shift from that to this, depending upon how many shift register we have or how many flip-flop we have. According to that it will shift. So it is nothing but a something called buffer operation. In middle there is some time delay. After that we are whatever input given that comes to the output side. This is exactly how the single bit operated in a serial in serial out shift register. So we will move on the next one called PISO. This is actually the toughest shift register in this part. and in this PISO we are giving in parallel in, but we are taking in serial out. Previous to SISO and SIPO we are done logic diagram very simply because the Q0 is moving to Q1, Q1 to Q2, Q2 to Q3, so simply we connected seriously D flip-flop. But in this case, we cannot do directly that one. Why? Because it is parallel in and serial out. So parallelly we have to give input. According to that, we have to get from the serial out. Already we discussed parallel in serial out means we are taking input from the portion called D0, D1, D2, D3 and output from the only Q3. So other output we are not bothering. So in this case, how to draw the diagram and how to make this working. So first here we have two operations. One is called shift operation, another one is called load operation. What is this load operation means? When you give parallel input, I have to load everything to Q0, Q1, Q2, Q3, whatever input is there that directly to this particular flip-flop. For this process is known as loading operation. So that operation we are making load as a 1 and shifting is not there. So what happens? Q0 is nothing but whatever you are given to D0 it will load, and Q1 means whatever you are loading to D1 it will load, Q2 means whatever D2 it will load, Q3 means whatever in the D3. So what happens when you give as a load option, it operates like a parallel in. So whatever input given to D0, D1, D2, D3, all the 4 input comes to the Q0, Q1, Q2, Q3. Then we require serial out. Serial out means we required in Q3 only, so it has to be shift, and from this answer I have to get only in Q3. For these reasons I required shift operation to be takes place. So for that we have to take S is 1 and whatever loading portion that is not required, so make it 0. What happens when first shifting is takes place? Anyway here I am not shown clock pulse. Each clock pulse only it is operating. So what happens into the first one? So here it is going to like as a D0 is shifted to this portion when first shift operation. Second shift the D1 shifts here and here D2 shifts. So it is shifting like this direction. And we are not bothered about what is there in the Q0, so don't care here. Next again I want to shift because I required output in Q3, so shifting is 1 only and your particular load is 0 only. In this case what happens? This D0 is shifted here and this D1 is shifted here, and other two conditions whichever left you can make, don't care. And once again we will go with the shifting operation and 0 here. Now what happens? This D0 is shifted here. This is nothing but the serial out. Whatever you are given, if you are given some number 1010, that same number comes here. So the first number anyway D3, then D2, D1, D0. This is called as our serial out. For this we require the circuit diagram. For that what is the operation going on here we will discuss. Now we will take as a shift and rotate. So shift and load, what is taking over here. First we will take here, this one is shift and this one is load. First we will discuss what is our Q0 answer. So here we are going with the Q0. What is the answer? For Q0, first one is actually D0 and other whichever not there, just fill it with don't care. So we can take as a D0 at what condition? S is 0 and L is 1. So S is 0 and L is 1, we are taking as a D0. And all the other condition, it may be anything because here we are taken only 0, 1 and 1, 0 condition. There is a possibility of both are 0. Both are 0 means no loading takes place and no shifting takes place. That is nothing but a don't care operation. If both are 1, that means serial shifting also and loading also together not possible. So when S and L equal, this condition usually we ignore. So other portion simply fill with the don't cares. So what happens? This D naught, we can make it all the groups. So D naught into this one, instead of previously 1 into anything, we will take as a 1. But this time we have to multiply with D naught. So all the numbers are connected. So 0, 1 cancel it out in the L and S also cancel it out. So we can call as a Q naught is equal to D naught. So moving on next one, if you're moving for the Q1, what happens to the Q1? You have to take same way S and L here. So in this case, when 0, 1, it is nothing but we are getting as a D1. So 0 and 1 case, it is D1. And what happens when 1, 0? So S is 1 and L is 0. This condition we have 1, 0 is D naught. So we are getting D naught here. So when you simplify this one, what happens? Other condition we can take as a don't care here. We can group it like D naught in the upper portion also and D naught in the horizontal or vertical portions also. Here I am doing with the left side D naught and it is from the direction like this, and you can do upper portion also possible. And if you take both the equations are similar way, and here all the four I am following this method. So when you make this one, so this is called as a S is 1 because L and 0, 1 L cancel out. So S is 1 you can take as it is, and there is a D naught present. So take D naught. Yes, D naught. This is equation what we got. In this when you take, you have to take something like that. So in this case what happens? The 0 in the S and L is cancel out. So it is S bar D1. Okay. The total formula for Q1, you can take that Q1 is equal to S bar D1 plus S D naught. This is what you are getting as a Q1. Next, important portion we are going with the Q2. When you are going with Q2, again we will take same way S and L. So when you take S and L, in Q2, the first we are getting D2 when S is 0 and L is 1. So S is 0, L is 1, we are getting as a D2, so take D2. The issue comes when it is coming to the D1 and D naught. Check here, both the D1 and D naught comes in the 1, 0 condition. So in 1, 0, I can write both the possibility D1 and D naught. So what you have to do, D1 and D naught already we have in the case of Q1, so go with that Q1 portions. So usually what happens, see here the D naught D1 already I have in the 2 portion. So same thing I have here also D1 D naught. So instead of taking both here, I will take directly as a Q1 operation. So here I have to take as a Q1. This is very important when you are considering these portions. So when you do the formula here, other portion whatever is there, simply fill with the don't care, because already I told when S and L both are 0 and both are 1, there is no operation. So 0, 0, 1, 1, you have to cancel it out. Then if you take like this operation, I already told you can take upper portion or the left or right portions. Here I am going with left or right. If you are going with upper portion, instead of S bar, you will get L bar. That is the difference. Okay. Yeah. Anyway, I will go with these portions. When you go with this portion, the S is 1. So yes, and here Q1 is there. So copy the Q1. Then plus we are going with this grouping. So it is D2 is there in the 0, that is S bar. Anyway, both the rows are connected. L is cancel out. So it is nothing but S bar D2. This is the equation what we got for Q2. Similar way we can go for Q3. What happens when Q3? It is similar way like L and S you have to take, and 0, 0 and 1, 1. This is don't care. Now go with the first portion when S is 0 and L is 1. so that is D3. S is 0, L is 1, that is D3. And other condition, when you check C, it is nothing but D2, D1, D0, all the portions are there. This is nothing but what are there in the Q3, Q2 also we have D2, D1, D0, same thing here, shifting. So we can take directly this one as a Q2. So when you do the formula wise, I already told we are taking left arm or right arm. So this is nothing but S bar D3 and plus it is S into Q2. Because S is 1 here, when you do grouping here, S into Q2. So according to these formulas, we are trying to do one particular block diagram. So we required input is something called S and we required one more input called S bar. So I will take S here directly straight line and one more I will take as a S bar. Now we will name the flip-flops. So already we know that this is our Q0 is LSB and Q3 is MSB. So we start from D0. This is D0, this is Q0, this is D1, this is Q1 and this is D2 and Q2 and similar way D3 and Q3. Here D0 means you are feeding some number. So that number you can take here from this and call D0 given to the first D flip-flop and taken from the output Q0. Next what happens, the Q1 is nothing but we are taking from S bar D1. So take one more portion called D1 here and here S bar. So take from here S bar and D1. So these two should be AND gate. Take AND gate something like that. And then S D0. So D0 is nothing but Q0. Both are equal here. So we will take from the Q0 also possible. Or you can take D0, no issues. So we are taking from Q0 and then we are taking from S. So here we have S. So take from S and take from Q0. So in this we are taking one more portion. So these are the two we take and then we are getting as a plus. So it is OR gate. Make it as a something called OR gate. And output is given to the next one, so it is D1 because the Q1 is nothing but D1, so we are giving to the D1. Always remember, when you are taking to the input, consider as a D. When you are taking from output, consider as a Q. If you take vice versa also, it is not at all wrong, you can take it. Next, we are moving to the Q2, so this output is nothing but SQ1 S bar D2. So we have to take one more input called D2. So take D2 here and from that you have to take one more card as a S bar. So this is S bar and here D2. Both you can take as a one more AND gate. And next you required as a Q1 and S. So you have to take from S here. This is your S portion and this is Q1. Both you are taking as a AND gate. So there is a 2 AND gate and from this we are doing as a 1 OR gate and output is given to Q2 is nothing but D2. So this is how we completed Q2. Now come to the Q3. What happens in the Q3? We require D3 one more. So go with the D3 and one more from the S bar. So this make it as a AND gate and then take the Q2 and nothing but S. So S is from somewhere here and you have to take for Q2 and make it AND gate. So you are done AND gate and these two you have to make as a OR gate and output is given to the D3. So this is nothing but the output and finally output you are getting from Q3. This is called as a serial out. In this way you can design PISO, parallel in serial out. The main aim is to remember in this parallel in serial out we are taking one extra input called shifting or loading. Actually this is S we are taken and S bar. If you are done here in the don't care, the upper portion, then you will get L. So you can call this one always reason when S is high, L is low. When L is high, S is low. So we can take something like S bar, L bar, nothing but shift bar, load bar. So this is the input 1 bit extra you have to take, and there is a 4 input we have taken D0, D1, D2, D3, and once input you have to always AND with the S bar, and you have to take always the another S directly to the previous output. That is the method we are followed everywhere. Check it out here. We are taken as a S bar D, yes or no? And here also SQ, S bar D. Either you can take D or Q, it doesn't affect, okay? Both are same. So don't confuse with D and Q. You can take whatever required or whatever easy for you. And always remember the another term particular, if it is Q2 means the particular D2 term, that is bar. And if it is Q3 means that particular D3 term is bar. So whichever that particular term that we are taking as an input portion and that we are taking as a bar. This way you can remember that PISO how we have to design. The simple block diagram I will discuss on this PISO. So this is how circuit diagram exactly look like this also you can do here. See, the D1 is connected here and this is nothing but S bar. Okay, so D1 S bar and this is S into previous Q0. Similar way it is going on. So like this block diagram also you can take it out. And actually how you have to get output when you give as a parallel portion. So these are called parallel input. You have to give 1010 any number to D0, D1, D2, D3. This is parallel data input. You have to get serial output. So only consider QD, and from QD the first bit whatever in the D0 that is appears here, and after that next number appears here and so on. So 0101 the answer what you are getting. So 0101 is the given number. So same number you will get here. So this way you can take serial in, parallel out. Last one is parallel in, parallel out. This is very easiest one. Nothing is there. Whatever input you are given that you will get output. So here D0, D1, D2, D3 are individual inputs. So this is we are calling D0, this is D1, this is D2 and these are D3. So here we are giving as a individual input. So we can give to any input here. So these are the input and we are taking from output here to the Q. So this is Q0, this is Q1. So here one more input and this is Q2, one more input and here Q3. So there is no interconnection between any flip-flop and whatever input you will give and you will get the output. There is no transferring, no shifting. This is the very easiest circuit ever. So these are we called as a D3, D2 and D1 and D0. These are called as a input. And here we are getting as a Q0, Q1, Q2 and Q3 and this portion we are calling as a out. So this is how parallel in, parallel out works.